mute myself.
Cool. Perfect. Hi, everyone. So welcome back to the first skills seminar of the semester. Super excited to have some of you back and maybe some of you first time. And yeah, so the skills seminar is just a trainee to trainee way of teaching each other how to do certain things in computational biology. Super open-ended. So if you're interested in presenting, please reach out. We would be super happy to have you. Oh, no. Yeah. All right. Well, hopefully you have grabbed some pizza and you're settled in, because I am so excited to have Stacy here today. And Stacy is a CCB designated emphasis student and PhD candidate in Dr. Peter Sudmant's lab in the Department of Integrated Biology. There they develop novel sequencing approaches and methodologies for characterizing structural variation in aging. Stacy also has extensive experience teaching and developing laboratory-based computational biology content for a lot of courses. For instance, Practical Genomics, the Berkeley Connect program in computational biology, and also the Cal Summer Genomics Research Experience, or Cal Genomics Summer Research Experience. And then you might also know Stacy from Python Bootcamp, where they are the head coordinator and content developer. So definitely check that out. They're awesome at teaching, can speak from experience. So I'm so excited for this and to finally learn some Snakemake. So, all right, take it away, Stacy. I'm gonna mute myself now.
Okie dokie, sounds good. All right, can people on Zoom just give me a thumbs up if you can hear me normally, just to be sure? Okay, great. Thanks, Emily. Thanks, Valeria. Super duper. All right, so this will come back. Don't worry about copying down this URL if you don't have it already. I think I'm also going to put it in the Zoom quickly one more time. All right, there we go. Let me hide this. Oop. Alrighty, great. So welcome to my little workshop. This workshop is on Snakemake. I hope that's what you're here for. And my goal is to really make this kind of like a gentle introduction to kind of what Snakemake can do for you. So we're gonna have, I like to do my workshops and like kind of teaching this way, where I have a little mini. I know, sorry, the room just got smaller. The room is small. Yeah, hi Hannah. Yeah, please someone sit next to me. I promise I'm not scary. Okie dokie. Hi Hannah. Oh, my friends are here. This is so heartwarming for me. Okay. Sorry. Anyways. Oh, that's with Carmel's. Yeah, sorry for people on Zoom. It's just they moved the room, so we're all like sitting in this circle and it's quite cramped. So maybe you're having a really great experience virtually. So anyways, the way I like to do my workshops is I always like to do a mini lecture before we do whatever it is that we're doing. And the idea is that even if you don't think that today is the time that you're going to get set up with Snakemake, I want you to know that this resource exists and that you can do it at any time, or you can refer to it again at any time. This is kind of written in the style of like a laboratory that you would do in like a teaching-based class. So why use Snakemake? So I'm going to tell you a little story about what I do. Monica introduced me, but I'd like to tell you why Snakemake works so well for me. And you can't even see all of this stuff, but I promise it's kind of funny. I'm classically trained as a molecular biologist. And right now my PhD work kind of requires that I use both my wet lab stuff and my dry lab stuff to do my whole project. That means that I am the person who is in the lab processing the samples. I am getting that DNA. I am waiting for samples to come in. I'm sending it to the sequencing facility, and then I'm waiting for the data to come back so I can analyze it and develop new methods to figure out where all these interesting mutations are. This means that I have a lot on my mind, and I like thinking about the hard intellectual problems and not whether or not I've processed file number 54 that belongs to sample number 99. I really don't like doing that part. And semi-recently, so earlier this year, I finally decided to start learning Snakemake because I spent a very long time being kind of like, I can't transition to using a different thing because I've invested so much in the way I do things now. And I think that that's probably a kind of familiar concept to a lot of you. But once I moved to using Snakemake, it really changed the way that I work, because it means that I don't have to spend so much time babysitting and project managing my work behind the scenes, I can focus on really understanding whether or not anything is working at all. I really hope that through this workshop, you can see ways where this can fit into your own workflow, and it kind of demystifies like what I think is a semi-rightful notion that getting this set up is hard, because I've tried to break down what I think is a lot of the onerous documentation on the Snakemake docs website into stuff that actually makes a little bit more sense to you. So whether or not I succeed in this, you'll have to tell me, but I'm going to try my best. So our learning goals for today is that I want to teach you about basic Snakemake. How does it know what to do? What do you still have to do? When is it going to do or not do things? I want to teach you about when you should use it and when you should not use it. And ideally, I want to give you, this example workflow that you feel comfortable running and you kind of know how it works, and you can use that to kind of scaffold and build your own workflows in the future. So for today's workshop, I have prepared kind of like a encapsulated little tutorial. It does require one thing though, called conda. So I kind of vaguely guessed that maybe a lot of folks in the room already know what conda is, or maybe have it installed already for one reason or another. But if you don't, mini conda is basically a super lightweight conda distribution that you can install like right now. If you feel like that's not the move for you, you can also use Data Hub. There are these two options, and they're both on this website that I'm going to show you again in 1 second. This github.com CCP skill seminar, Snakemake Fall 23. I will wait a few seconds for folks to try and do that. If anything, I just want you to open the GitHub and look at the stuff that is on there so you are convinced that there are materials for you to look at later, if you have your laptop. Yeah, all you have to do is just go to the live tutorial setup section, click on that, and it should have the several commands you need to run in order to get set up. I'll wait just a little bit, so if there are any early problems, you can flag them with me right now. And then I'm going to start talking through the mini lecture. And people on Zoom, please let me know. You can either, Monica, you're able to see the Zoom chat, right? Can you let me know if there's like a question there, because I'm hiding everything? Okay. Oh, nice. All right. Give me a thumbs up in the room if you're like at least like 20% on the way to doing this. All right, great. Okay, so there's only a few commands, and it's okay if the installation takes a little bit. Basically, it's just going to download, or like rather, you need to copy this repository. You can git clone it or download it however you wish, and then you need to set up a conda environment. That's going to just take a few minutes, so I wanted to get that set up while I talk. Otherwise, we might be in a situation where like we have 5 minutes and you're setting up everything. So while that's going on, I'm going to explain how Snakemake works. So Snakemake tries to model workflows using a directed acyclic graph. It's okay if you don't know what that is, because I'm going to go through some examples. But basically, Snakemake models a situation in which you have several tasks in a workflow that you want to do, and there are files that go in and then files that come out, or something that goes in and then something that comes out. And it tries to relate these in a way where it understands if you want, let's say, a file that is file E on this thing, then it must contact the jobs or get files from jobs A, C, and D. And D needs things from B, C, and A, blah, 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 so on and so forth. It's a little bit abstract, so I'm going to go over examples that are more like something that you might actually do. So let's look at a toy example. let's say that we have 2 samples from something. I work with a lot of sequencing data, but this could be really anything, just 2 specimens, IDs, anything, where you got to run a certain analysis and then create a plot. So you have your first file, you have your second file, and you do some random analysis and you get an output file, and you do the same random analysis, or that should be sample 2, whoopsie doodle. And then you combine these with a plotting function, a package, a program. This could even be, God forbid, Microsoft Excel if you want to use that, I don't know. And you create a plot, all right? You probably do this all the time. Analyze something, put the data together, make a summary. So let's think about how Snakemake will handle this workflow. I'm trying to write this in a way where it's like, this is what Snakemake is thinking. So we want all samples dot plot. What do we do about that? We want it, what do we do? We think about what generates all samples dot plot. Okay. It's this program called Your Favorite Plotter. Now, what does that need? It needs 2 files, your sample 1 analysis and your sample 2 analysis. Now, where do we get those from? We can get both of these through running a tool called some random analysis. Okay, so we want to run this tool. What does this tool need in order to generate sample 1 analysis and sample 2 analysis? It needs sample 1 file and sample 2 file. And then it goes and it finds those files. This is how Snakemake tries to handle, okay, we want to create a file, what do we have to do? It goes all the way back and it thinks through every single thing it needs to get this. So you don't have to do that. This, if you set it up correctly, will just do it for you. And this is super useful in cases in which you just have tons of samples or you're working with samples from different groups, like you want to do something like this. Also, please do come and sit. There's one more chair right here. It just has some stuff on it. Just didn't, I think, CCB just didn't realize that it was going to be like an extremely standout popular event, but we're doing our best. So that's how Snakemake would ask these questions and parse through stuff so you don't have to. Let's go through some more examples of how this, can be more useful in a practical setting where maybe you're not just always working with a known quantity of files. So let's say that you, for some reason, were doing an analysis and then you maybe got some new samples, or that you stopped your analysis in the middle because you had to go eat dinner and then you came back and you're like, wait, what did I do? You can still say, well, regardless of what I did, I want this plot and it should have all my samples. And Snakemake will go, well, you get it through using this program. Do we have all the files to do this yet? And if the answer is no, then it's like, well, we need to correct that. We need to run this analysis. And then once that's done, it'll create the file for you. So even if you are like me with the memory of a goldfish, it is okay because Snakemake will think through this for you. And on top of that, let's say that you did an analysis, but it's been like, I don't know, let's say that you went on a long ski vacation and then you got some new samples and then maybe you ran some of them, but not all of them. And now you don't know if you have everything updated. So you have an existing file and Snakemake can check for you whether or not that file has the contents of everything else in your, let's say, sample database. If it doesn't, it'll say, well, that's not right. We got to update that. And it'll run the update or what's necessary to do the update, and then update your output file. And this doesn't have to just be a plot. This could be anything. This could be a table. This could be some sort of, even just some random file, for example, like a pandas data frame saved as a pickle or something like that. Because Snakemake doesn't actually check what does the file look like. It checks things like the metadata of the file. What time was it created? What jobs pointed to it, what samples are tagged onto it. Snakemake handles all of this for you. So you don't have to do what I think a lot of us have done in the past, which is actually manually check when you created this thing, see if you wrote at the end of the thing, it's final, final, final. You don't have to do any of that. So I'm going to talk through this kind of example workflow, and this is soon we're going to talk about the stuff that you've hopefully set up on your computer. A workflow of a short read analysis. I tried to pick something that could be maybe somewhat familiar to most people in the room, and I tried to pick some sort of an organism to work with that can run quite quickly, even if you're working on let's say, Data Hub, which runs at like potato speed when there are a lot of people on it. So please bear with me as I talk about this extremely implausible circumstance. You are a fabulously wealthy researcher. Already we're there. Okay. And your two greatest passions are genomics and sourdough bread. Maybe it's like 2020 and like you're like trapped. And you want to do science so bad. So you decide to do this survey of sourdough starters. This is actually a real survey that someone did. I didn't realize that until I made up the scenario and I went hunting for data that people actually did this in 2021. But anyways, you decide to do like a PopGen study of sourdough microbes. You pick a very interesting one called Fructolactobacillus sanfracinensis, which is named after San Francisco sourdough bread. And you decide that maybe there is something very interesting about this bacteria. Maybe, despite its name, it's globally distributed. Maybe there are unique little SNPs and mutations in San Francisco Fructolactobacillus sanfracinensis that are not present in the Germany version or something like that. Because you're extremely rich, you can just self-fund the study and you decide to gather the data. But you are also with low patience. And once the data comes back, you realize that you kind of just want to get the analysis over with so you can go back to doing the thing where you just make and eat delicious bread. So you want to kind of like outsource the analysis as much as possible. So you turn to Snakemake. So if you have not done this kind of analysis before, it's okay. It's not really important to the concept of why Snakemake is helpful. But if you have, I wanted to show you the steps. In this little tutorial I've prepared, Snakemake will take care of everything here on this list. It will download example data from the NCBI sequence read archive. It will pre-process reads. It'll map the reads. It'll sort some of the output reads in a BAM file, and it'll create some summary plots. And I also use Snakemake to generate this little diagram. So that's another feature of Snakemake I'll tell you about later, which is that if you struggle to convey what is going on in your analysis to other people, Snakemake is a great way to just be like, here's a picture. That's what's happening. It's quite nice. So if you are not familiar, again, with short read analysis or any sort of genomics, just think about it as the data goes in and the picture comes out. That's what Snakemake is going to do for us here. Jerry. Oh no, I'm sorry. Yeah, sorry for the room change, everyone. I didn't know until this morning either.
For a good few minutes, I'm like, this is not Stacy teaching Snakemake.
So wait, the room was empty? So we could have been sitting in there?
No, it was somebody was teaching a class in there.
Oh.
It was like vaguely biological, so I was like, I sat there for a few minutes thinking, maybe this is an intro.
Oh no, I'm so sorry. All right, well, you're in the right place now. Okay, so I already talked through a little bit of the setting up the workflow. My disclaimer here before I show you like any of this stuff is that I built all of this from my experience, but it's not the only way that Snakemake works. It's just what I think works for me, and I've tried to keep it minimally fussy. So you don't have to do anything in here that doesn't make sense to you, or you're looking at it and you're like, I would never process things in this way. That's okay, because this is a management tool and not an analysis tool. As long as you understand why it works, you're in good shape. So let's get started. So if you have already cloned the repo or downloaded it or gone into Data Hub and gone to the right place, this should be what your working directory looks like if you are in the right folder. There might be some more files and stuff inside the directories, which is fine, but it should kind of look like this. Give me a thumbs up if this looks familiar. All right. If you don't have this right now, also like now raise your hand and tell me. Okay, great. So this is what it looks like. And as I go along, I'm going to highlight the direction of each thing. So, or that way, if you want to crack it open in like VS Code or like in a text editor, you can do that. I'll show the contents too, but just so you know that this is all real stuff you can look at. So one of the basic frameworks of Snakemake is a sample table. You need this because it will help Snakemake organize things for you. And also because you probably have something like this already. You can use any table that has, at the minimum, a column that contains unique identifiers or keys for the specimens or samples that you wish to process. I don't even think it necessarily has to be a completely unique column. For example, we could imagine a situation in which the top specimen up here, this 907 specimen, has multiple files associated with it. That's fine. But as long as you have a column that you can use to at least track the specimens in the way that you would think about specimens, like I have 1, 2, 3, 4, 5, or something like that. That's the minimum. I personally add a bunch of metadata in the other columns because I usually reuse this table for other analyses, and it's just easy to keep everything in one place. If you want to look at the subset sample table, so there is a longer full sample table and then a subset for this tutorial, you can just peek at it right there. The subset should only have 2 or 3 entries, and the full table should have like 12. Just for the sake of speed, because I really don't know how everyone's computer will run today. You can pop a look at this. So, rules. So Snakemake knows to do what it does because there are things called rules in its configuration. And you are the one who has to write these rules. I have already modeled some of them for you, and I'll show you some of them shortly. But this is the major task that you have to do for Snakemake, which is tell it how you want it to make things. So if we look at this graph, each of these nodes here, these little things with words written in them, is a rule. And a rule describes how a task should be run. For example, if you want to run some sort of shell command, the rule will say, run this shell command. If you want to, I don't know, like edit some text using like sed or grep or something like that, you can also write it in there. You can also tell Snakemake to run a script. It can do a ton of stuff. And by convention, rules are stored in files with SMK extensions. These are basically just text files, so they're not some sort of proprietary thing. You can literally just double click on it and open it with a text editor and see that there's a bunch of stuff in it. Ideally, each SMK contains multiple rules that relate to some sort of modular task you want to do. So for example, I have one SMK file called getData, which contains a couple of rules that will help us download the data for our tutorial today. Pre-processing contains several rules that help us with the pre-processing of our data. The idea is that these are really just modules that help you know where things are. And if anyone ever needs to read your code, they also know where things are. So don't, and I'm not saying this like I'm like lecturing you, I'm saying this because when I started, I did it. Don't create just one big SMK file and put everything in there. It's just a bad idea. It's a bad idea. Don't do that. Try to be organized. Try. So this is kind of what a snippet of one SMK file looks like. For example, this one is the pre-processing SMK file. There are 2 rules here. So these rules both correspond to kind of a little bit of QC work on short read sequencing data. You see that there are a few entries here: input, output, conda, etc. And these are all things that tell Snakemake how you'd like this job to be done. So let's break it down a little bit. Okie dokie. So I've just gone and I've picked like an easier to read rule that does a very specific thing. So the first thing underneath the rule that is a mandatory or usually pretty mandatory input is the input field. So this declares like paths to files that you need to be necessary for the task. For example, this one is to trim sequencing adapters from reads, and reads are stored in FASTQ files. So I tell Snakemake, you should expect that this rule needs to be run with FASTQ files. You'll see that in the little input field, there's FASTQ equals this thing, and there's a little like section in curly braces called ID. That is kind of, if you're familiar with Python, it is like a placeholder for when you format a string. If you don't know really what that means, it's kind of like a fill in the blank kind of situation, where if you have configured Snakemake correctly, Snakemake will take your sample table and then be like, okay, what are the IDs in the sample table? and it will be like, okay, we have IDs 1 through 5. So we're going to run this rule on sample 1 with ID 1, sample 2 with ID 2, sample 3 with ID 3, et cetera, et cetera, et cetera. So that way you don't have to manually type in every single file path, because I've had to do that before and you will always make typos. So that's why this fill in the blank system works quite well. There's more discussion about exactly how this works, like inside the files I've written, and also in the Snakemake documentation. It can be a little bit tricky, but I've tried to keep it simple and mostly intuitive here. Okay, next is the output field. So the output is, you're telling Snakemake, when you run this command, or you run this job, you do this task, it should create a file. And Snakemake will need this to see like, okay, if this thing runs successfully, I should see a file like this. So for example, if we successfully run this rule to trim reads from, let's say, sample 1 fastq, we should get an output that is sample 1 trimmed fastq. I've marked this one with a temporary flag, this thing in the little parentheses, because Snakemake also has this really fun option where you can tell it to automatically clean up stuff that you don't need after it's done being used. I don't need this file anymore later in my workflow because I actually do a few more QC steps on it and I only want the final file. That way I don't have to dig through mounds of like normal fastq, trimmed fastq, filtered fastq, sorted fastq. I can be like, I only want the one that has everything done at the very end and just please automatically clean up all of the old stuff. Isn't that great? I personally love that, especially because I really hate when my folders become like super big and packed with files that are impossible to parse. And probably if you use Savio, the people on Savio will love you for this too. Stop using so much scratch storage, they say. Okay. And last, this is the, you don't listen, yeah. We've gotten some personal emails. So the last mandatory thing, the example here is shell, which is saying to Snakemake, run this command at the command line in the shell. I want to note here that it's not the only way you can run stuff. Like Snakemake lets you run almost anything you want. Like you can run Python code, you can run R scripts, you can do whatever it is that you want in this like option. I just put shell because I thought it was the most likely thing that people would be familiar with. So you'll see it's basically like I would run this command normally if I was doing manual analysis, except I would have to fill in all of the things in the curly braces myself. But because Snakemake is able to automate this for me, it fills in all the blanks for me in a systematic way. Oh, sorry, go on.
So, you mean I can replace the shell with Python, then it will run the Python without using the shell?
Yeah, for example, if you used instead of shell and then the colon, you could do Python and then colon and then be like, you know, like panda stuff, numpy stuff, like scipy stuff. You could do it there. Or you could just provide it an existing, you know, .py script, and then it could run that for you too. All right, Valeria has a question. I don't know where the sound will come from though.
Can you hear me?
Monica, will it come from your laptop?
Hi.
I can turn my laptop sound on if you turn yours off.
It's just that I cannot. Oh, I can write a question. I can write it.
Okay. Okay, I'm going to turn my sound on. You can just tell me.
I think she said she read it.
Oh, you're writing it. Okay. All right. 1 second. Uh-oh.
Well,
That was not what I wanted. Uh-oh.
Valeria does that.
Oh, God.
Oh.
What is happening? What has happened to my Zoom? Oh, boy.
You're
All
still
right.
on my screen.
All right, then I'm just going to pretend like that never happened. All right. I can't access my questions panel, so you'll have to read that to me.
Yeah, Valeria still have like anything.
Okay.
But I want to ask.
Mhm.
Yes, so there's like 2 different ways of getting parameters. There's a dictionary.
Yeah. I'm going to talk about that later. Okay, Suzanne, go ahead. You talk.
Yeah, I was wondering, do you feel like if Snakemake is better for like a top-down analysis pipeline, like after I have my dev in mind? Like what if it's more like a UTA? I don't really know what I'm about to do in the next step. Is that still?
Oh, it's still fine. I use Snakemake when I'm working on stuff and I have no idea what's going on yet. And then I also use it for when there's a full workflow I want to run. If anything, it's really helpful during the development stage because it also helps you keep track of all the different things you're testing. I'll talk about why that is as we go along.
Okay,
So.
we have 2 questions.
Okay.
So Valeria says, so this would be the file that I will use to submit a job in Sudmant.
Oh, yeah. So you can do that too. I'll talk about that at the very end. There's a guide that does the Savio explanation like way better, but Snakemake, I should have said that at the beginning because I just realized a lot of you probably use Savio. Snakemake can take these rules and it understands that you want to do jobs that you tell it to do. And instead of running it on your local machine, it can just submit jobs to Savio, like through SBatch. So you can also do that. I personally use the interactive mode a lot. So I like will run like I just have a super powerful local machine because I am very anxious and I like to watch things happen. But if you are fine with just SBatch, you can do that too. Takes care of a lot.
And then there's another one,
Mhm.
and I'm typing your answers. If you were to pass in a Python script, how do you handle the wildcards?
How do you handle the wildcards? That's a good question. So you can handle the wildcards using curly brackets and then doing like wildcards dot whatever ID. There is an example of this actually in some of the rules, but if you can't parse it from there, I'm happy to talk to you after. I'm going to keep on going though, because we have 19 minutes and I want to make sure that we have a little bit of spare time. So this is, again, like I said, a simple example, but the code that I've written is quite, I've tried to document it as much as I can. So now I'm going to talk about the optional stuff. And this is like my opinion about what stuff that is optional, but I think it should be mandatory because it's really useful. So threads. So a lot of programs support multi-threading, which is really great, especially if you're running something on Savio. You could just tell Snakemake what is the maximum number of threads or allotted threads you want to give to running something. And in this way, you don't have to like manually type that in every time. And even if, for example, let's say that you're thinking like 5 threads is a lot to this thing. I only am going to have like, let's say like 20 on my system. Snakemake takes this as a maximum and it will scale for you if you don't have like the appropriate amount of computing resources. It manages all of that for you. So you can look at the threads parameter as like a very optimistic, like if I had like this many like cores or threads available, use this much. Snakemake also supports log files. So if you are like me and you chronically forget to send things to a log file, even if there's an option, if you just set it up once here, it'll just automatically write to this file. It'll like create it like from scratch. So I like this option a lot because if things go wrong in the middle of your workflow and it creates a file, but let's say it's empty, at least you know that you can go read the log file because it's systematically generated alongside everything else. And last but not least, and I'm going to talk about this more because I think that this is actually really important, Snakemake supports individual Conda environments for each job you're doing. So if you have been managing your way through your analysis by making Conda environments from scratch and then having to activate them, but then you forgot to do it, and then you did it in the wrong thing, and then maybe you upgrade things and then something broke, and then you just decide to bin Conda, I promise you, this will solve all your problems. Okay, that's a bold claim, but I think it'll solve a lot of your problems. So if you've never done this before, the good news is that I think that it's pretty simple because you would have had to do this anyway while creating a Conda environment manually by doing like Conda install whatever. When you use Snakemake, you can provide it something called a YML or a YAML file with instructions on how to create a Conda environment. All you have to do is create a file. I usually like to name these files in ways that match my SMK like files. So that way it's like very clear what the relationship is. You can see like I really make these things because I have a goldfish brain. And for example, the Conda environment that I showed, that I asked you guys to install with earlier, Snakemake Fault 23, has a name, Snakemake Fault 23. It says, hey, Snakemake and Conda, please download packages from these channels, and these are the 2 big ones for computational biology, and install the following packages or dependencies. You've seen that I've hard pinned like everything here because I want this to like stay stable as much as possible. You don't have to do that. But in my general practice, if you only have like 4 things that you absolutely need to install in your environment, then you should just pin them if possible, because Snakemake will install everything else, or Conda installs everything around it flexibly. So you no longer have to deal with this problem where, let's say that you have a Conda environment and you swear that you only wanted to download, let's say, Python, pandas, NumPy, and let's say matplotlib. But then when you list everything in your environment, your screen explodes and there's like 100 things installed. And it's impossible to understand what you put there versus what had to be installed in the background. If you list things in a YML file, it is way easier for you to debug any problems that come up because you know that these are the specifics you wanted to install, and everything else that may break, like for example, htslib always breaks for me, then I know it's not like, oh, I installed that manually. That was installed because of, for example, like SAM tools, and I said SAM tools should be this version. It just makes it easier for you to not have to deal with non-intellectual problems. This is my preference. You don't have to do this, but it's my preference.
Just about
Mhm.
see. So, for example, if you can just take a Python version 3.0 or something, but in case of pigments, you don't specify the versions.
Exactly.
What happens if I don't specify the
Yeah, so I usually will do things where, like, if I know that things will update a lot and it's likely to change the way that things work, I'll pin them. I didn't change Pigments because Pigments is just a library for, like, Snakemake needs this to make the little cute workflow graphs, and it's just a graphics library. I don't think that's going to, for example, fundamentally change the way that we do short read analysis, but maybe the plots will get ugly or something, and I'm okay with that. But for things that I think I would be pretty upset if it broke, I will pin it, like pandas. Because of this example I showed here, a bunch of packages that I use just said, oh, in their YML file, like install pandas. But if you have a version of Python that's a certain level, if you have this thing or that thing, and then Conda tries to install everything in the newest version, the package doesn't work anymore because pandas updated a bunch of syntax about a year ago for data frames, and now everything's broken. So it's kind of a trial and error process. I don't have the best recommendations, like, about what to do if you are trying to balance between being up to date versus making sure that everything's stable. There are better solutions for stuff like that, like Docker and Singularity, which I will tell you as a flag right now. I don't know how many of you know about this or use it, but Snakemake is also great because it lets you containerize your workflows too. So you can just make it into a Docker container. If anyone understood those words, you might be excited, but if you don't, just ignore that. Yeah, right. Go you.
We also have a question. Can you use an already made environment?
Yes, you can. Yes. To be clear, Snakemake will take these YML files and then make new environments, and it will name them according to the MD5 sum of the contents of the file. So if you change the environment file, Snakemake will update the environment automatically for you. I think that's great too. Go on.
Yeah, so I think I have a question on dependencies. So these dependencies are essentially speaking Python libraries, but like often the time we use tools which are not supported by
Supports
Python.
R.
So can Snakemake actually handle the installation for those?
Yeah. So everything that's supported by Conda, it works. I believe Conda supports things like downloading R, as well as things that use like you can do like pip installs too. I think there are some exceptions, like where, like, for example, let's say you got a package where the person is like vigorously allergic to package management and you can only install it from source. In that case, I can discuss what I do after the tutorial, because I have, like, for example, beta builds of things that like aren't managed here, and I sort that out through a different thing. Okay, yeah, Conda could be its own entire other workshop, so please let me know if you have questions about it separately. I'm happy to talk about Conda a lot. Okay, and then we're almost at the end, I swear. This is the third file we're talking about, and then there's a fourth file, and then we try to run things. So the second to last thing is called a config file. A config file is the thing that I think that someone asked earlier, like, oh, like you have this reference to some parameter and it's inside a config. What is that? A config file is something that at its baseline, it tells Snakemake where your sample table is. So for example, I have made these cute little commented blocks to keep these things separate. So we tell it, oh, your sample table is located at this path. I also like to put additional config options for my little jobs, because I really hate going through all my Snakemake files to figure out what I told cutadapt that it needs to like trim reads if the overlap is this length. I like to just read them all from this config file, because it's way easier to manage things if they're in one place and you don't have to dig through all of your files to find everything. So in my actual practice, like I have a bunch of stuff for, like, for example, my read alignment parameters. I have a bunch of stuff for like filtering. I have a bunch of stuff for like which annotations are connected to a reference genome. All of that information, I put it in my config file, because it's just easier to understand what's going on from here. And the last part that I'll tell you about in a second, like I'll tell you that these files are very easily swappable. So just another highlight, this is what was happening earlier. If you saw in the rule that I showed you that there's a parameter for overlap and it refers to this config, this is where it pulls it from. You just parse it like it's a list of a list of lists. So I think this is way better than having to be like, oh dear, did I change every like a value for this thing if it comes up repeatedly, like in a reference genome? You don't have to do the control F, the even through VS Code. Like it's just way better. I like this so much more. Okay, we're here, we're at the end. Okay, so the last thing you do is a snake file, and a snake file is just like a file that says, all right, this is where the configuration is, and then we want to use all of these rule modules. So this is the reason why I told you not to make one giant master thing with the idea that you'll just comment out what you don't need. Because if you just contain them in separate modules, you have to comment one line instead of like intersperse chunks throughout your giant file. I made this mistake like 4 months ago. I just don't want you to do it the same way. And if you are like me and you frequently work with, like, for example, different reference genomes or different databases that you're kind of like wanting to swap in and out, you can just make different config files and then just point to different ones in here. So for example, I work with different human reference genome builds like HG38 and CHM13. I have one for CHM13, one config, and then one for HG38, one config. And that way I can manage all of the different annotations and other stuff associated with those independent reference genomes without having to control F my way through every single part of my analysis.
When you say you have different config files, do you have like the storage with template config that you use, or do you just specify the path for every like different? I guess I don't understand exactly for different pipelines that you have. Different
pipelines, yeah. So like you could store your config files wherever you sort of wish. Like in this situation, I put it in a folder called config inside this directory. But many people will just have like, you know, some folder full of like, for example, like these templates, and then when they have an analysis directory, they'll like do a symlink, or they'll just give it the full path to a config, so on and so forth. I usually try to also like keep version control on these with GitHub. So that way I can really easily also compare, like, to make sure that my config files are like right. Many people for like established workflows only have one config because it's like with very stable settings. This is just in the case of, for example, development, is that I'm still trying to figure out which parameters are right. So I might have like stable config and then like development config. Yeah.
A question from Sue. Do you prefer the config YAML and samples TSV instead of a JSON file?
I personally like writing YAML files better. I can't speak to really like the JSON setup, but I feel that the concept is quite similar. I just use YAML files for everything. They parse very reliably and they're quite easy to write, like fewer brackets and stuff. All right, so we're heading to the last bit. If you're on Savio or you have a pretty powerful computer, you should be ready to do stuff very soon, and it should run in a handful of minutes. The way that you tell Snakemake what to do is you use a version of this command. You tell Snakemake _, you give it PJ number of jobs that you want it to spawn at maximum. You tell it to use conda, and then you give it the file path that you want. I'll show you an example in a second of something that you can run right away, and it should work, God willing. I usually will set n to just the number of cores I have available, or something like that, because it's a ceiling. It's not a mandatory thing. Even if you, for example, only have 8 cores, you could tell it PJ 40 and it would be okay. It would just not spawn that many. That's just the ceiling. So in our example workflow here that you can fully explore later, we can generate several summary plots that should hypothetically require the full pipeline to be run in order to get to the final summary plot. Like, for example, a VCF heat map. That corresponds to this terminal node that you can kind of see on the screen that's at the very bottom in red. The best way to test this stuff out is to do a dry run first. So if you don't have to look at your screen to copy, or like you don't have to look here to copy this down. It's on the GitHub repository homepage. Just scroll down to the command section and you can just copy that and fill in the right number of n. Try running that and you'll see that Snakemake will think really hard for a second, and then tell you what jobs need to be performed. Once you see that, and if it makes sense to you, then you can take off the NP flag and run it for real. I'm telling you that you should always dry run, because sometimes you'll find mistakes in your workflow because things just aren't set up correctly.
What's the definition of dry run?
Dry run is kind of like, I don't actually know what the origin of the term is, but it refers to like, pretend like you're doing this for real, but don't actually do it. So like in the laboratory, when I dry run something, I pipette water instead of actual expensive reagents. That way I can tell how long something would take and what I need and make sure everything is there. So you're doing like a rehearsal. This is very useful for when you don't want to just, just YOLO your workflow and maybe like use up all of the compute resources on your server. You just want to see, what if I did do that? What would happen? And in that way, you can debug much faster than having at the very end, oh, wait, it didn't actually generate that file. So if your setup worked correctly, you can try a dry run. Ideally, you can even try the actual run by taking off the NP flag. I tried to time this a few times this week, and DataHub is, like I said, can be very potato slow. So if you're using that, it might not be ready yet, but on local or on Savio, you should be able to do this.
Stacy, so I'm from
Mhm.
So for the n in between curly brackets, we substitute with the course we want.
Yeah.
Not for the n.
Not for the NP. Yeah, if you don't know what to put inside the curly brackets like N, like the PJ, like N, just say 10. I'm giving you the permission to just use 10. 10. Yes.
So it's showing like the error message unrecognized argument.
Okay.
PJ and
Okay. Give me 1 second. I'm gonna walk over.
Is that, should there be a space?
Yeah, should there be a space?
Yeah, maybe a space.
Oh, there should be a space. Oh.
Yeah. If you're not sure if you're typing it right, the GitHub homepage does have a command section where you can like copy paste or like fill in things. That way there shouldn't be any typos. Okay, maybe just type those double dashes normally, because sometimes there's weird formatting problems.
There's independent workflows,
Mhm.
mail script and multiple files or
Mhm.
they be run post-synchronically.
Yeah, you could just, here I'm only putting one file, so for the people typing manually, they don't have to type like a bunch, but you could give it many target files at the same time.
And then run independently.
It will queue up all the jobs needed to do those at the same, like in parallel, like at the same time. Maybe I don't fully understand the question, but I can talk to you about it after. So.
The issue for me was instead of double dash, just single.
Oh, is it single dash? Okay, damn. I was trying to fix the thing earlier. Okay, if you're not getting it to work, it might just be 1 dash. Sorry if you're having problems with that. I'll change it on the GitHub thing. All right, bye guys. I'm gonna flash past this because I don't think it's particularly important for you right now. But as you're doing this, as you're running things, if you would also like to have an actual picture of how this works, Snakemake supports that through a graph generation option. I actually put this just on the GitHub repo. It's not commented out in the snake file anymore, so you can just run that command from there. And it can generate even sample by sample what needed to be done for each sample. Obviously, you don't want to use this option if you have like 50 samples because the graph will be incomprehensible. Oh God, why did that all? I did not try to make these animate, so like, I don't know why it's doing that. Okay, so in the very last like 30 seconds, I know I'm running over time. This is obviously a basic Snakemake tutorial, but I wanted to flag that if you have more advanced usages, I have yet to find something that Snakemake just like straight up doesn't do. So for example, if you need a large number of target files and you don't want to type them all in, you can just use make configuration to get them all to generate at once. You can write helper functions for things that Snakemake doesn't support directly, but you want to implement in Python. You can submit to Savio. Snakemake can calibrate memory usage for you in case your mapping keeps on failing because of a memory dump issue. It can run Jupyter notebooks. It can even make little HTML things so everyone thinks that you're like a front-end developer god. It can do all of these things for you and more, including Docker stuff that I didn't put on here. So I'm going to stick around for a little bit and answer any questions that people have. Thank you so much for listening. If you want to stay in touch, my contact info is up here and on the GitHub page. And please sign up for the future skill seminars. Everyone puts a lot of work into these. And thank you for your time. Yay!
Thanks everybody for coming. Yeah, so stay on the lookout for a feedback form that will send up to this. And yeah, if you're eager to learn more Snakemake and more about reproducible analysis, you should come to the next skill seminar where Stacy's labmate Manny will be presenting.
Yeah.
And you might build on what you learned today.
Yeah, he's going to be presenting on how to use this to like generate figures for papers and make everything in your paper super clean so the reviewers will be happy.
Yeah. Thanks so much.
Thank you, everyone.